In the last part, we acquire a small sample of car data using a web scraping tool, with a goal to understand how options and specs affect car prices in the used market. In this part, we want to train a regression model to predict the price of a car for the given spec and options. When you have tabulated data like this, and you want to predict something based on it, there are two kinds of tasks you can do normally with it: regression or classification. To put it simply, regression is whenever you want to predict a continuous value based on a set of features. In our case, the features are the option or spec list. Whereas classification predicts a discrete value. Think about true or false or recognition tasks like identifying dogs, cats, pandas, or lizard. Now there's a vast library of machine learning to do the task. Which one should we choose? I always have a golden rule of thumb. For any data, as long as it's tabulated like this, a classic gradient boost decision tree is the best. Things like XGBoost or light gradient boost machine, or LGBM for short. If you want to learn more about boosted decision trees, there should be plenty of tutorials online. I especially recommend a task given by Petro Tabakov, which is linked in the description. I could go deeper on the debate on which method is the best, but LightGBM tries the deep learning method on this task because it is explainable, which is crucial to our next part of the video. And you also have the upside of the simplicity, so it gives you the best bang for your bucks. So I loaded up the 150-ish cars data and trained a regression model predicting the car price. Again, the training code is linked in the description below. I have to admit though, given the 20-ish features, normally I'll be comfortable with at least 10 rounds of iteration. However, because we have so little data, we choose to have a much shallower tree in order to have a larger number of trees. For reference, for a dataset with 20 features like this, I would prefer to have at least 50k samples to have an accurate model. However, for the demo purpose, this little data will certainly do. Next, we want to explore the cost of a single option. Now you might think this is an easy problem. You can just set one example to missing all the options and the other one with just the option you want. However, things might not be so straightforward. There are lots of things to consider, including feature codependencies, which we will explore in the proper way to do this in the next part.